Perhaps most of us have forgotten the precise day. It was June 3rd, 1965. But not many of us will forget the experience of seeing Ed White leave the open hatch of Gemini 4. He said simply, "All right, I'm out." EVA, which began so successfully with this 20-minute walk in space, was not so easy in later flights. We scheduled 5 more EVAs, lengthened the time, and added space work to the flight plan. But we gave the astronaut too high a workload to perform, and the problem was compounded by the pilot's difficulty in positioning himself during work periods. Now we were coming up on the last flight and the last EVA, with questions about EVA still unresolved. And Gemini 12 would launch in 60 days. Part of the answer may be found under the water of this pool, where we have submerged mock-ups of the spacecraft and Agena target docking adapter. We had done research in underwater simulation of space conditions for some months. Now, for the first time, a flight crew will incorporate underwater simulation into their EVA work training. In an inflated pressure suit, astronaut Edwin Aldrin, pilot for Gemini 12, is weighted with 60 pounds of lead. He is positioned at the prepared Agena workstation by trained scuba divers. Underwater simulation creates a condition of neutral buoyancy. It gives the pilot an effect quite similar to that of zero gravity. Astronaut Aldrin has attached himself by a waist tether to rings on the Agena. From past EVA experiences, we learned that astronauts spent far too much energy trying to stay in position while working. Waist tethers are one of the restraints that we are investigating for Gemini 12. The jobs now performed underwater by pilot Aldrin are those which will be done on Gemini 12. Attaching handholds, using a torque wrench to tighten bolts, making electrical connections, cleanup of his work area. In short, the type of jobs we know are basic to space station work. As he will during flight, pilot Aldrin has moved by handrails from the Agena workstation to the adapter area. He is now ending a rest period. We have carefully planned the rest periods of this EVA in relation to the workload. Leaning backward, pilot Aldrin tests another type of restraint used in the adapter area, special foot restraints. These are also called Dutch shoes by some people for obvious reasons. The chief advantage of underwater simulation is that it gives a training EVA pilot continuity of tasks. As such, it is a valuable addition to zero-G simulations in aircraft, where the zero-G condition is attained in the parabola of flight for only 30 seconds. Pilot Aldrin and his backup crewman, Pilot Cernan, are able to simulate the entire EVA exercise of Gemini 12 without a break, step by step from the beginning, as it is written in the flight plan. They run 2-hour simulations underwater several times and finish training almost on the eve of launch. On November 11, 1966, the Atlas Agena target vehicle for Gemini rendezvous and docking lifted off the pad at Cape Kennedy, 7 minutes after 2 p.m. Eastern Standard Time. Gemini 12 was now slightly more than an hour and a half from launch. Command pilot for the mission was Jim Lovell, already a veteran of the longest manned spaceflight, 14 days on Gemini 7. In the 4 days ahead, he would log more hours in space than any other man. His pilot was astronaut Aldrin. The Agena was inserted into an orbit of 164 nautical miles by 159 nautical miles. Mission Director Bill Schneider gave the final go for the launch of the last Gemini. Liftoff came at 3:46 Eastern Standard Time. The launch vehicle propelled the spacecraft as smoothly as it had in 11 previous flights, and Gemini 12 was headed for an orbit of 146 by 87 nautical miles. The first order of business after insertion into orbit would be an M=3 rendezvous, or rendezvous during the third revolution. Maneuvers proceeded according to plan. A radar lock-on with the Agena was reported at 235 nautical miles, and the crew sighted the target using a sextant telescope at 85 nautical miles. But as the distance decreased to 64 miles, the crew reported erratic radar response.
Roger, Warner. I wish we had lock-on followed up the Agena. He's still having negative luck with all that, huh? Roger, we'll proceed as with the radar failure.
The crew immediately went to a backup rendezvous mode, onboard computations. The pilot bent over his charts, relaying distance and burn rates to the command pilot.
Burn at 2 plus 05 plus 48. I should put it in here.
This method had been used successfully as early as the Gemini 9 flight and presented no problem.
12 Houston, 1 minute to LOS. You can go encoder on.
Roger.
Have fun.
But still it is interesting to note that the pilot making the computations this time had written his doctoral thesis on just this subject, rendezvous modes. Dr. Aldrin was as calm as though he were sitting in the graduate stack studying. And Command Pilot Lovell brought Gemini 12 to a station-keeping position at Tenerife, 3 hours, 46 minutes after liftoff. He began making his preliminary docking approach. He will dock south of Japan within range of the tracking ship Coastal Sentry Quebec, or CSQ in the flight controller's call letters.
Is he docked, CSQ?
That's negative flight.
Okay. You satisfied with the Agena?
Both vehicles are go.
Okay. Let him know that.
Okay. Gemini 12, CSQ. Roger, CSQ. We're giving you a go for docking. Roger, thank you. CSQ. Go ahead. Point on dock. Roger.
As docking practice continued in the third revolution, Pete Conrad, the Capcom on duty, broached a problem to the crew. It concerned the Agena Primary Propulsion System, the PPS.
The problem appears to be one that indicates a possible turbine pump problem. And we're going to give you a go a little bit later on as to whether you can make the PPS burn or not.
There had been a momentary drop in the pressure in the thrust chamber of the PPS during insertion. It then returned to normal. But that 1 second drop in pressure was enough to bring the Gemini specialists onto the floor of mission control. The pressure drop could cancel plans for the PPS burn today, which would inject the docked vehicles into a higher orbit of 400 nautical miles. The decision came in the fourth revolution and was relayed through the Hawaii tracking station.
Well, Hawaii, you're no go at the present time on the PPS burn.
The big burn, such as we saw on Gemini 10 and Gemini 11, was out for this mission. But the crew was given no chance to settle back for a couple hours free ride, or crack open a good novel, even if they had one aboard. Mission Control came up with a substitute plan. It was this. Tomorrow, Gemini 12 would take photos of the solar eclipse over South America. For eclipse phasing, Command Pilot Lovell would make 2 Agena burns, but with a smaller secondary propulsion system. And one more change. The crew would go to sleep an hour early, but they would wake up 2 hours early. Hawaii bid them good night on the 5th pass, and summed up things to this point pretty well.
been kind of a busy day. Thanks much. That about does it. And flight says to tell you good night.
Two major events faced the crew on the second day after they were awakened by the Canary station.
Gemini 12, this is Canary Capcom. Canary, this is 12, loud and clear, over. Ah, you're loud and clear. Good morning. How'd you have a good sleep? Oh, so, not bad.
2 solid hours sleep, they said. This has been the pattern of past flights. You doze off and on during the first night and settle down to regular sleep the next night. But they were ready. First for eclipse photography, then a stand-up EVA. Gemini 12 was in good position for the eclipse. The command pilot shot time exposures for later scientific study. The stand-up EVA began over the Canaries. The hatch was open at 19 hours, 29 minutes into the mission. Pilot Aldrin reported that he had only a minor tendency to float upward and had no difficulty in maintaining the position he wished in the open hatch.
Okay, I'm just drifting here. It looks like I have a small tendency to float out, but very little. A beautiful view.
There was also preparation for the umbilical EVA of the following day. A portable handrail was installed from spacecraft hatch to the cone of the target docking adapter. It was left in position to be used Sunday. A major portion of this EVA was devoted to star photography, shooting so-called hot stars, much of whose light is in the ultraviolet spectrum. 80% of this is filtered out by the Earth's atmosphere. From Gemini, astronomers can study data unobtainable from the Earth. After 2 hours, 28 minutes, the hatch was closed and the crew was repressurizing their cabin over Canton Island. Jim Lovell reported, "It was a pretty good exercise, and I'm starving to death." The flight director was obliging.
Neat period for you starting at 2300 to 2350.
Sunday morning began rather abruptly, shortly after 3 a.m. by the clocks at Manned Spacecraft Center. Flight Director Krantz woke the crew about an hour and a half early to check out fuel cell operation. He took one bulky stack off the line. The crew was then invited to nap a little longer. Waking up early for one reason or another would be a feature of this flight. But the crew seemed to like keeping a farmer's hours. They declined sleep and went to work, taking another bite out of the 14 experiments of the mission. On the 27th revolution over Carnarvon, a go was given for the umbilical EVA and space work. EVA began over the South Pacific beyond contact with the ground. Mission control could only wait it out until the spacecraft passed over the States and into tracking range. How was it going? We had restudied work in space for this flight. We replanned our tasks, and it was a last chance for Gemini. But waiting is sometimes a hard job. How was it going? Onboard cameras show us that it was going pretty well indeed. Pilot Aldrin moves out the hatch along the portable handrail, which he had installed during the stand-up EVA the day before. He attaches a tether from the Agena to the spacecraft. That tether would come in for some good use later today. The spacecraft was now passing over the United States, and Mission Control received its first news of what was going on. Buzz Aldrin was at the Agena workstation. While working, he is attached by a waist tether. This gives him a secure position, and he has both hands free for the job. Doctors were counting his heartbeat closely during the work period. So far, it had been pretty much below 120. After finishing up at the Agena workstation, Aldrin makes his way along the handrails to the hatch and the rest period. At this time, he is at the adapter area and has been conducting the EVA for more than 40 minutes. Although we have no onboard film of the adapter work area, the pilot performed 7 tasks there, much as we saw in the underwater simulation. When we next pick up the EVA on film, the astronaut is again at the Agena workstation. He tests the waist tether and comments, "The restraints are good. I don't see any problem in positioning my body at all." The next assignment is use of a torque wrench on a bolt. The same type of job had been performed at the adapter section. The wrench can be set for any value from 50 to 200 inch-pounds. He had performed 19 tasks, 12 at the Agena station, 7 at the adapter. A good EVA work session. Now, like any good workman, the pilot sets about cleaning up his work area. "Okay," he said, "workstation is clear." As he got back in, Jim Lovell greeted him with, "Okay, here's your seat, Buzz. That's it."
Gemini 12, Houston Capcom, 1 minute to LOS. New EVA record, beautiful job.
That new record was 2 hours, 9 minutes on umbilical EVA. Command Pilot Lovell undocked from his target vehicle 47 hours, 31 minutes from liftoff. He was between stations, between Carnarvon and Canton Island. Command Pilot Lovell is backing off slowly from the target vehicle, pulling on the 100-foot Dacron tether attached to his spacecraft during the umbilical EVA. He will now attempt to extend this tether until it loses all slackness and becomes taut. As expected, that takes a bit of doing at first. The tether whips back and forth and develops loops. But if the command pilot can position these two vehicles on the tether, the one lower as the Agena is, and the other higher as is Gemini 12, there will be a very slight difference in the gravitational pull of the Earth upon the two. Small as it is, this difference may be strong enough to stabilize the spacecraft and the Agena. Now Gemini 12 is in its second daylight pass of this exercise. Jim Lovell has his tether extended and taut. He turns off both spacecraft and Agena control systems. The tether remains taut. The two vehicles move through space, maintaining their positions without use of thrust or fuel, a technique important for future space missions. After 4 hours and 20 minutes, the tether exercise was ended. Command Pilot Lovell jettisoned the tether. The mission had now lasted 51 hours and 51 minutes. It was time for the crew to separate from their target vehicle. They would perform a 6-foot-per-second posigrade maneuver to give them sufficient clearance. Target vehicle and spacecraft went their separate ways, and the crew slept. The next day was Monday, and it began for the crew at 1:15 a.m. over the Rosenaught Victor tracking ship. The crew had a third and final EVA ahead of them. It was a stand-up EVA this time, devoted to ultraviolet photography. But there would also be an opportunity to jettison some excess EVA equipment no longer needed. The hatch was opened at 66 hours, 11 minutes. The pilot took ultraviolet photographs of the sunrise and of selected constellations. After 51 minutes, the hatch was closed, and with it, the crew had closed out 3 planned EVAs with remarkable success. Not long after this, Gemini 12 received its flight update for a 60-1 recovery. It would now fly the full 4 days and come down in the primary recovery area in the Western Atlantic. Tuesday, the 4th day, began on a familiar note. The crew was awakened early. Flight Director Krantz was checking the fuel cells again, but no major problem. Although the more dramatic segments of flight were behind Gemini 12, the crew was quite busy completing outstanding experiments. A preliminary retrofire time of 94 hours was transmitted to them. Suddenly, a lot of time seemed to have gone by very quickly. 19 months since Virgil Grissom and John Young walked up this ramp, the first crew for the first 2-man spacecraft. It hardly seemed possible. So matter-of-fact it was that Gemini 12 was making its last pass over the Canaries and the last pass of the Gemini program. There were brief words with other old friends, Kano, Nigeria, Tananarive, Carnarvon, Australia. And we are 1 minute from retrofire. Mark.
All aircraft are on station as of 1849-0.
The network SRO. Go SRO.
Roger, I have an IP for you from our computer.
Okay. Discovery.
24 degrees, 44 minutes north.
Flight, understand me.
The prime recovery ship, the USS Wasp, was on station some 600 miles east of Cape Kennedy as the retro rockets fired. The Wasp waited, as she had on 4 other occasions, for Gemini 4 and Gemini 6, for 7 and Gemini 9. Slightly more than 30 minutes to wait, with her helicopters scanning the sky. The spacecraft is entering the Earth's atmosphere at 400,000 feet. We have a chance to make the last ride down with the crew, looking out the pilot's window. This film of re-entry was shot at 6 frames a second. We are projecting it at normal speed, 24 frames, so our ride will be just a little fast. Heat of re-entry becomes intense. Particles flake off the ablative heat shield and fly onto the window. The intense heat will now break off our communication with the ground for about 4 minutes. We are midway across the continent, near the Mississippi Delta. The crew has been coming in for 27 minutes. Communications blackout is over. Our ground station talks to Jim Lovell.
Well, Houston, our data shows you're right in the money. Roger.
Less than 10 minutes to splashdown. Main parachute sighted, in full view of the Wasp.
PRD Atlantic Chief, from the Wasp, they estimate the range of 5 miles to starboard. They see a yellow-orange chute, estimating altitude 2,000 feet.
The slow descent was followed down to the water by cameramen and relayed to the nation by television.
Well, Houston, we've got you on the move, too. You look good.
Splashdown. The Gemini 12 flight is officially over at 2:21 p.m. Eastern Standard Time. It passes into history. The recovery mission begins. The Wasp was almost alongside the spacecraft as it splashed down. Rescue swimmers were in the water with a flotation collar, ready to check in with the crew. Jim Lovell was the first to be lifted into the waiting helicopter. It returned immediately with a sling to pick up Ed Aldrin. Both were soon aboard and receiving the congratulations of the helicopter crew. There would be time later to summarize the Gemini program, to add up the major accomplishments we now take for granted. Rendezvous and docking, long-duration missions, EVA, pinpoint re-entry. There is a just share for contractor, for Department of Defense, NASA, for flight crew and ground crew, and most of all for the man in the street for whom this program is ultimately designed, and without whom it has no meaning. But this day belongs to Gemini 12 and its crew. We must not stint them. These men set out to do a job and finished that job thumbs up. Command pilot and pilot had added 5 hours, 28 minutes of EVA exposure to the Gemini record. Each established his own individual record. Jim Lovell has flown longer in space than any other man, 18 days. 14 days on Gemini 7, 4 days just behind him. Buzz Aldrin set his record of 2 hours, 9 minutes on umbilical EVA at workstations. The crew increased our experience at tethered station keeping after successful rendezvous and docking. Finally, Gemini 12 added 14 successful experiments to the Gemini program, which has collected research data for scientists on every flight. More than 50 experiments were conducted on this program. In the tradition of manned flights, the Gemini mission flag is lowered for the last time at the Manned Spacecraft Center. As it comes down slowly, we hear an echo of the words of the program manager. It is now time to go on to bigger things. And we will be able to go on with confidence because there was this program, and it was called Gemini.